Hey guys, my name is Daniel. I'm here once again with you from the Challenger Learning Center with two very exciting experiments, and I have the first one right here. Take a look at this. Watch closely. I have this balloon and this a soda can right here. I am going to move the can without touching the can, but just using the balloon. Look at this. Look at that. That is so cool, right? Now, you might say, that's a magic trick. Oh no. That is all science based on static electricity, okay? Before I show you how this first experiment is done, and granted I have two to show you, I did want to give you a rough or a basic background about static electricity, which happens all around us and we don't really think about it too much. Question for you guys, actually two questions. Have you ever maybe rubbed your feet or your socks on a carpet and maybe touched a doorknob and got shocked? Or maybe you helped your parents take out all the laundry out of the dryer, and maybe if the lights were off you saw like some sparks, or maybe you got shocked with that. All that is due to static electricity, okay? Static electricity by definition is just the buildup of an electrical charge on the surface of an object, okay? And the reason it's called static electricity is because all the charges stay in one area on an object for some time and don't flow or move for that time. Now, atoms all around us are made of three things: neutrons, protons, and electrons. Okay, the two I want you guys to focus on are protons, which are positively charged particles, and electrons, which are negatively charged particles. Now, a static charge with static electricity happens when two surfaces touch each other and the electrons move from one object to the next. And one of the objects has to have a positive charge and the other a negative charge. And when you maybe rub an object very quickly, like you rub your feet on a carpet, or if you rub a balloon in like your hair, this will help build up a charge in those objects. And to build on this, items with different charges, so you have your positive and your negative, those attract. Think of like a magnet, okay? A north pole and a south pole on a magnet attract. North and north, or south and south, repel, or they push away. A very similar idea here with the positive and the negative charges. So if you have a positive and a negative, those attract. If you have a positive and a positive, or a negative and a negative, those repel and want to push away from one another. So let's jump on into our activities here. Like I said, I have two very exciting activities to show you. Kind of got a sneak peek at the first one. So what we're going to do is build up a charge on the balloon. You can either rub this through your hair really quickly. The longer hair I found works better, but I've even found a better method to really build up our charge on our balloon. I have a wool scarf. Anything with like wool or something like that, I've found works out really well, like wool socks or something. And you just rub that on the balloon a few times, and you can maybe hear some crackling on it. You know that charge is really building up. That's all you need, just a quick rub on that. And then take your can, place it on a flat surface like that, and without touching the can, put the balloon close to it. You might need to go one way or the other to see what works out. Once it gets rolling, it should go. And that is moving your can without even touching it, okay? What's basically happening here is that you have electrons that are built up on the surface of your balloon right here, because we rubbed it quickly with this scarf. You can rub it in your hair. So your negatively charged particles, your electrons, are in the balloon, okay? And this is called static electricity because it's non-moving electricity. It's just a charge built up in this object. Now the electrons have the power to pull very light objects like a can. This has a positive charge, and like we said, negative and positive charges attract, and therefore the can wants to be pulled toward the balloon. Now, I want you guys to try something further than this at home. I want you not only to see if this works for you guys and how to really build up a charge on your balloon to help the can move, as maybe see how fast it can move. But also, maybe does the size of your balloon affect the speed that you can pull your can? Think about that. You can even try different shapes of balloons, like long ones or shorter ones or even smaller ones. Also, does the length of maybe your hair affect how much charge is built up on your balloon? Or how about this? This is pretty cool that I would love to try, and I want to see what you guys can do with this. Fill up your can just a little bit with water, not all the way, but just fill it up. That way, when you can put it on a flat surface, that it doesn't pour out, of course, but just put a little bit of water in the can and see how much water you can put in the can until the balloon cannot pull it anymore. Okay, see what that maximum level is, the maximum weight of water in the can. So that's some things to think about, okay? So that is activity number 1 for you guys. Activity number 2 is pretty cool. Let's go ahead and get this ready. All you would need is, you can use a comb or a balloon. I've tried it with both objects. Here, I'm going to set my can aside. You just need something to build up, again, your electrons, your negatively charged particles on the surface of either one of these. I found that the balloon works better. Once again, I'm going to rub it with my wool scarf here to really build up that charge. And come on over to the sink with me. I do want to have the water on a steady stream, but pretty thin. You don't want this, you don't want water gushing out like that. You want a thin stream like that. Okay? And we're going to take our balloon here and we're going to bring it closer to the water. Oh my gosh. Do you see that? Look at this. Look at this. Look at this, guys. That is incredible. Look at that. What do you think is going on? Oh my goodness. That's amazing. So let me tell you how this is working. Okay, here's a quick visual of what is going on with this experiment. So on the left you have your comb or your balloon, whatever you have at home. When we either rub the comb through our hair or rub the balloon with our wool, that of course builds up our negatively charged particles on the surface. Now, a water stream, a basic water stream, is neutral in charge. So all of the molecules, all the negative and the positively charged particles, they're just basically scattered throughout the water. Okay, so therefore it is neutral. Now, when you bring the comb or the balloon closer to the water stream, all your particles separate. So your positively charged particles go on the side closer to the comb or balloon, and the negatively charged particles go on the opposite side. Okay, and then when you bring the comb even closer, the positively charged particles closest to the comb or balloon are of course attracted to the negatively charged particles in the comb or balloon, and that causes the water ultimately to bend toward the comb or balloon, whichever one you have at home. Pretty cool stuff, right? It's pretty basic, but it's very, very powerful what's going on here. Some things for you to further experiment with at home with your water bending experiment. 1, does water temperature perhaps affect how much the water bends? Try cold water, maybe lukewarm water, hot water. Just work with an adult when you guys do these experiments. And yeah, make sure to work together on this. 2, does the size of balloon or maybe even comb, if you have that at home, does that affect how much static electricity builds up on the surface and how much the water bends? Thirdly, does the amount of moisture in the air affect the amount of static electricity that is used? Try it maybe after someone takes a shower. Try it in the bathroom sink, okay? See how much the water bends based on how much moisture is in the air. Also, does the material that is either in the comb or the balloon, does that affect how much static electricity is able to be built up? So some things for you to experiment with these 2 activities. I did want to close with some safety precautions of lightning. Now, lightning, which I'm sure you guys know, is associated with all sorts of thunderstorms and weather that we have here in the southeast. Now, lightning is also static electricity. It's just on a much larger scale here. It's very powerful and of course very dangerous. Did you know that temperatures in a lightning bolt can reach up to 50,000 degrees Fahrenheit? Just think about that for a minute. Now, weather down here in a typical summertime climate can reach maybe over 100, okay? 100 degrees Fahrenheit. That's pretty hot, right? Now think about the temperatures in a lightning bolt. That's a lot hotter than our weather outside during the summer, okay? So lightning safety, whenever you hear thunder, that means that lightning is occurring. So you need to get indoors immediately. Either seek shelter in a building, an enclosed building, or a car immediately, okay? Now, the key here is that you need to wait at least 30 minutes, okay, after hearing the last thunder before returning outside. That way you are completely safe from any lightning strikes, okay? The saying is, when thunder roars, go indoors. Say that with me. When thunder roars, go indoors. Always remember that. Very, very key that safety is a priority here. Well, guys, I hope you learned a lot about static electricity. I would love to hear from you guys how these two experiments went for you guys, what you maybe changed with them, and maybe how the results were improved, or maybe how they changed somewhat. Stay in touch with us, and I look forward to hearing from you guys, and I will see you next time.